Good day everyone, I'm Christina Delamina and together with Miss Eileen Tabile, we will be reporting the fiber optics. We'll start with defining fiber optics. Fiber optics is the technique that sends information as light pulses via a glass or plastic fiber that is known as fiber optics or oftenly called as the optical fiber. These glass fiber can range in quantity from a few to several hundred in a fiber optical cable. When glass was first drawn into fibers during the Roman era, fiber optic technology began to emerge. The optical telegraph was developed in the 1970s to send signals from one location to another. Towers were outfitted with a number of lights. The first optical fiber laser was built and operated by Elias Schnitzer, who was recognized posthumously by the Institute of Electrical and Electronics Engineers on Friday. Over the course of more than 4 decades, Schnitzer made contributions to photonics research that paved the way for the fiber optics technology that powers the Internet and other communications networks. Elias Schnitzer and Will Hicks performed the first glass fiber demonstration in 1961 by passing a laser beam through a glass fiber. These two American scientists used lasers to pass light waves through a glass fiber that was only a few microns thick so that the light waves would go in a straight line rather of bouncing around and mucking up the signal. This was a significant development, but a more fundamental issue prevented meaningful contact with light. No one knew how to make typical glass clear enough to transmit light very far. Typically, light traveling along a fiber loses nearly all of its energy within only 30 feet. Moving on, we have the three key components of optical transmission system, which is the light source, the transmission medium, and the detector. According to conventional wisdom, a light pulse denotes a 1 bit, while no light denotes a 0 bit. A very thin glass or plastic fiber serves as the transmission medium. When light strikes the detector, an electrical pulse is produced. A unidirectional data transmission system that accepts an electrical signal, converts and transmits it by light pulses, and then reconverts the output to an electrical signal at the receiving end, is created by connecting a light source to one end of an optical fiber and a detector to the other end. Optical fibers can be used to create links with higher bandwidth. In addition, let's also tackle the transmission of light through fiber. Optical fibers are made of glass, which in turn is made from sand, an inexpensive raw material available in unlimited amounts. Glass making was known to the ancient Egyptians, but their glass had to be more than 1 millimeter thick or the light could not shine through. Glasses that are transparent enough to be useful for windows was developed during the Renaissance. The glass used for modern optical fibers is so transparent that if the oceans were full of it instead of water, the seabed would be as visible from the surface as the ground is from an airplane on a clear day. The following topics will be explained by Ms. Tabile.
Ms. Lamina already talked about the three major characteristics of fiber optics. So now, let's talk about the three components of the fiber cable. An optical fiber generally consists of three concentric elements: the core, the cladding, and the outer jacket, and also called the buffer. The outer jacket, it is the main physical protection for the cable. It is also provides a smooth and safe touch for its users. The next one is the cladding. The cladding in optical fibers is one or more layers of materials of low refractive index, causes light to be confined to the core of the fiber by total internal reflection at the boundary between the core and the cladding. The last part of the fiber cable is the core. The core is usually made of glass or plastic. The core is also the light carrying portion of the fiber. Why choose optical fiber over copper cables? Compared to copper cables, fiber optic cables are thinner and lighter in weight. Fiber can withstand more full pressure than copper, and It is less prone to damage and breakage. Let's move to fiber optics specifications. The first specifications of fiber optics, it is the attenuation. The attenuation, it is loss of signals measured in decibel. The next one is the dispersion. It is blurring of a signal affects the bandwidth. The third specification, it is the bandwidth. The number of bits per second that can be sent through a data link. The last specification of fiber optics, it is the numerical aperture. The numerical aperture, it is measures the largest angle of light that can be accepted into the core.
Thank you for listening, everyone. God bless.